Cisco Certified Network Associate Day 3 PM. Welcome back everybody, this is Imran Rafa, your trainer for this entire series. Today, as you see on the screen, we would be dealing with subnetting, and like I discussed in the last video, subnetting is a very easy concept. Once we master subnetting concept, subnetting can for most part be done on your head and you don't really need a pen and paper. And I think once you watch this video well, and if you try to learn everything that I'm going to put in here, I'm sure all of you can do subnetting in your minds. When I started preparing this presentation, I realized subnetting is going to be a large topic which I cannot cover in one video. So what I'm going to do is, in day 3 PM, I will cover subnetting for class C IP address. For class A and class B IP address, I will have another video, and let's call it day 3 late night. So we'll call it day 3 LN. And I will have class A, class B subnetting, and I will have another concept called supernetting covered there. So let's not waste much time. We'll get straight into day 3 PM. We will deal with subnetting. What is subnetting? We discussed in our last video, subnetting is nothing but breaking down a large network. Now if you consider the room that is shown on the screen, it's a large room, but just by putting this one wall in between, this large room is broken down into 2 separate rooms. That's exactly what subnetting is. Subnetting is taking a large network, breaking it down, and treating them as separate networks. Now to understand subnetting, we need to talk a little bit about IP addresses. There are 2 types of IP addresses. You have the private IP addresses and you have the public IP addresses. What is a private IP address? Private IP addresses are addresses in this range. So we have, for class A, we have 10.0.0.0 to 10.255.255.255. That is nothing but 16,777,216 IP addresses. In class B, 172.16.0.0 to 172.31 to 255.255, and that is 1,048,576 IP addresses. In class C, we have 192.168.0.0 to 192.168.255.255, which is nothing but 65,536 IP addresses. Now, what are public IP addresses and private IP addresses? Private IP addresses are IP addresses that cannot go on the internet. So if a internet web server gets a packet which says source IP address is 192.168.1.1, that packet will be immediately dropped, because these IP addresses are the private IP addresses and they can only travel in your local network. So in today's situation, internet assigns public IP addresses to your routers. So you have routers which will have which is public facing or internet facing, and they will get a public IP. Computers in your local LAN will all be assigned a private IP by your router, maybe router, this device that is facing the network. So that's how internet works in today's scenario. But when IP version 4 was designed, the designers hoped that IP version 4 would be used in such a way that all the computers on the internet would have a separate unique IP addresses, unique IP version for IP addresses. Because when they designed that, they thought there are 4.2 billion IP addresses in this 32-bit IP version 4 address, and they thought that would be enough for the whole world forever. So maybe they did not anticipate internet to grow as it grew in the last couple of decades, and very soon they realized they would run out of IP version 4, and that is when IP version 6 was designed. And also concepts like NAT, which we will learn later, which is nothing but network address translation, and private IP came about. Now what happened is, when internet started growing so fast, many devices, every human being today, you have a computer, you have an iPad, you have an iPhone or any phone, and all these phones and all these devices also try and connect to the internet. Now 4.2 billion is a very, very small address space for an internet that is growing so fast. So when NAT and public private IP came about, it reduced the number of IP addresses that had to be assigned to each computers, and each computer in today's scenario does not have an IP address that is internet facing. So the whole design of the internet had to be changed when the internet, the IPv4 addresses started running out. So in those days, what happened is, because of the class full IP addresses, when any company, let's say a company had 2 computers or 10 computers, when they went to the internet and as an internet service provider and then told them that they wanted an IP address, they wanted internet for their companies and companies' devices, and they wanted IP addresses, they would allocate, let's say for instance 192.168.1.0 range. Now 1.0 range /24, according to how we discussed in the last video, it has 254 IP addresses, but the company had only maybe 10 computers, so it literally wasted about 244 IP addresses. Now that is what happened, and internet IP addresses were running out very, very fast, and that is about the time when they realized that there was a need for subnetting, where they could break down these large networks and treat them as separate networks. So before we go into subnetting, let's do a recap and let's see how Class C IP addresses work. So Class C IP address 192.168.100.225. Subnet mask is 255.255.255.0. When we convert it into binary, this is what we get. And knowing what we know from our previous video, we know that the separation of network and host happens here, and this is nothing but /24, right? Because there are 24 ones. According to the formula, 2 to the power host, the number of host bit is 8 because we have 8 zeros, minus 2. So this Class C network has 254 valid hosts. When you make all the host bits as 0 of your IP address, that is the network ID of that network, and IP addresses in that network can go from 1, 2, 3, 4, 5, 6, 7, 8. It goes on until all the bits of your host part becomes ones, which is nothing but a decimal equivalent of 255. So if you put that onto a pie chart, 0 is like the first IP address and 255 is the last IP address. So you have 1, 2, 3, 4, 5, 6, 7, 8 and all the IP addresses within this range, right? Okay, let's get into subnetting. Now is when we get into really interesting things. Let's take the same IP address 192.168.100.225. Subnet mask is 255.255.255.0. That is your Class C IP address. First thing we need to know, the minute you say subnetting, we go into something called classless. And when you see /24, whenever you say slash notation, it is nothing but CIDR notation, and CIDR stands for classless interdomain routing. Now once you start doing subnetting, like I said, you take the whole concept of class full addresses and you throw it out of the window. So from now onwards, we are going to deal with classless IP addresses. So we would take 192.168.100.225. This is Class C IP address, so it's a /24, but we cannot say it has Class C anymore because we are doing subnetting and we will be dealing with CIDR. So let's say we want to break this network into 2, as you see here on the screen. So it's like an apple. If you take an apple, give it 1 cut, it breaks into 2 pieces, right? So to break a network into 2, we borrow 1 bit as shown here. So initially this was the host part, so these were all zeros according to Class C, but we want to do subnetting. So what we do is, from the host we borrow 1 bit. So instead of the line being here, the line now will be here, right? So this is the network part. right? Now, the minute you see subnetting, we need to find out the network ID and the host ID for these two separate networks. Now, these are two separate networks. You have subnet 1 here, and this is subnet 2. So we need to find the network ID of each of these subnets and the broadcast ID. How do we do that? We see the subnet mask and we see the last bit. Last bit is this. This has got a place value. If you remember this place value, 128, 64, 32, 16, 8, 4, 2, 1. This has got a place value of 128. That means each of these subnets have a block size of 128, including 0. So when you say block size is 128, minus 2 is 126, which is nothing but the number of hosts it can have. So 126 hosts plus you have one network ID and one broadcast ID, which will be 128. So what do we do? Let's do this. The network ID of the first one is always 192.168 and make this part 0. So that is the first network. That's the first subnet, and that's the network ID. To get the second network ID, all you do is add the place value. So network ID of your second subnet is 192.168.100.128. How do we get the broadcast ID of these subnets? You do is minus 1 from 128, so it is 127. That's the broadcast ID, and of course you can't go beyond 255, so 255 is the broadcast ID of second subnet. That's all there is to subnetting. So subnetting is nothing but borrowing a bit from your host part and create a network. So you're breaking this network into two. So borrowing one bit. So originally, if you remember, subnet mask was 255.255.255.0. Now the new subnet mask, because we borrowed one bit, this part, so let me take another color. This part is now the fourth octet is nothing but 128, because 1000 is nothing but 128 in decimal. And as we know, because we have now /25, because we have 25 bits in the network, but these addresses are going to be /25 addresses. Right, now that is nothing but subnetting, and it's very easy. To understand this concept a little more, we will take another example. Now you get an IP address 192.168.100.225. Subnet mask is 255.255.255.192. We'll convert the subnet mask into binary. That will be this, and if you see, the original separation was here. Because of this new borrowals, our separation is here now, right? What is the last bit? The place value of the last bit is 64. So each of these subnets will have 64 as the block size. Another way of doing it is, if you take this, we know that the whole network is 256. Divide by 4, it becomes 64. If the block size is 64, each of these subnets can have 62 valid IP addresses, and you can find that obviously by using this formula. Number of zeros, 2 to the power number of zeros minus 2 is 62. The network ID is 192.168.100.0. that's the first network's network ID, making this 0. Keep adding the place value of the last bit, so 64, 0, 64, then add another 64, 128, add another 64, it is 192. How do you get the broadcast ID of these networks? 1 minus, so 64 minus 1 is 63, 128 minus 1 is 127, 192 minus 1 is 191. This is the broadcast ID of each of these subnets. And this, as we know, is /26, because 192 is nothing but borrowed 2 bits, so it is /26. For class C borrowing table, I've made a small table to make things very easy. When we borrow 1 bit, the mask value becomes 128, if you see here. So it is going to be 255, 255, 255, 128. When you borrow 1 bit, it creates 2 subnets. How do you know 2 subnets? It's very easy. 2 to the power number of bits borrowed. 2 to the power 1 is 2. The block size, as we see here, if 1 bit is borrowed, block size is the place value. So 128 is the place value. Number of hosts is always 2 minus the block size. CIDR is /25, because it was 24 class C, you're adding one more /25. When you borrow 2 bits, the mask value becomes 192. That is 128 plus 64. So the mask value is 255, 255, 255, 192. It creates 4 subnets. If you borrow 2 bits, 2 to the power 2 is 4 subnets. Place value is 64, so that's the block size. Number of hosts is always -2, it's 62. CIDR is /26. Similarly, for 3 borrowed bits, mask value is 2 to 4, as you can see on the bottom of your screens. That is also got by adding wherever you have 1. So 1, 2, 3, 128, 64, 32 is 2 to 4. 4 subnets, host is 32, -2 is 30, CIDR is /27, and the block size, you see the last bit's value, it's 32 is the block size. So similarly, 4 bits is this, 5 bits if you borrow this, 6 bit if you borrow, this is the value. I wouldn't want you to remember this entire table, but I would want you to remember this value. So whenever you see 1 bit borrowing, you can know the subnet mask is 128. If it is 2 bits is 192, 3 bits 2 to 4, 4 bits 240, 5 bits 248, 6 bit is 252. So this is going to be a magic number, so just remember this number. I think that is going to be very, very, very easy. And of course, the block size can be derived by looking at this magic table. And the CIDR, obviously, you can see how many bits you're borrowing. You just add that to 24 you have. So this is pertaining to class C. We will be discussing about class B and class A in the next video. Alright, let's get into some problems. We will try to understand subnetting a little more. We have a requirement. It says create 3 subnetworks. Use a class C IP address of 192.168.1.0. And it says determine the network ID and broadcast ID of all the subnets. First, what do? Can we break a network into 3? No, we can either break it into 2 or break it into 4. It's always in multiples of 2. So to create 3 network, we break it into 4 networks. If you want to break it into 4, we know we have to borrow 2 bits, and the last bit's place value is 64. Then we know that each of these subnets have a block size of 64. That is 64 minus 2 is 62 valid hosts in each of these subnets. How do we get the broadcast ID? How do we get the network ID of each of these subnets? Start with 192.168.1.0, add 64, add 64, add 64. 0.0 is here, .64 is here, .128 is here, .192 is here. These are all the network ID of each of these 4 subnets. How do we get the broadcast ID? 64 minus 1 is 63, so that is the broadcast ID of this network. 128 minus 1, 127. 191 is the broadcast ID here, and 255 is the broadcast ID here. Very simple. And questions like this, determining the network ID and broadcast ID, is going to be part of your CCNA. So start creating the solutions, So start doing all these calculations in your mind. It's going to be very, very easy, and in your exams you will not have much time. It'll be very fast. They'll ask you a question, and if you spend more time on that one question, you're going to waste a lot of time later in your exam. So immediately you see a question, quickly get the network ID, broadcast ID, and answer it. Let's look at another question. So your question is going to be something like this. You will have an IP address, they'll give you a subnet mask, and they'll tell you find the network ID and broadcast ID of this particular IP address. Quickly, we say 1/27 we know is 24 is class C, 25, 26, 27, so that is 3 bits. So as seen on your magic table, 3 bits. That means each of these subnets have 32 bit, or each of these subnets have 32 as a block size. That means it has 30 hosts each of these networks. We start at 192.168.225.0 as your network ID of the first subnet, and keep adding 32. So 0, 32, 64, 96, 128, 160, 192, 224. That's your network ID. How do you get the broadcast ID? 31, 63, 95, 127, 159, 191, 223. Now, where does this IP address come? 192.168.225.212. each of these number represent the last octet. So 212 comes here. That means the question, our answer for this question to find the network ID and the broadcast ID is this: 192.168.225.192 is our network ID, and 192.168.225.223 is our broadcast ID. So in our exams, you will just have a question like this, and they'll give you 4 options, and immediately if you do this, you can know that this answer is the right answer. So you don't need to waste much time. Quickly you can go to the next question. Alright, next let's get into another concept called VLSM. VLSM stands for Variable Length Subnet Mask. In all our previous examples, we broke down a network into equal parts. Now that is not feasible in many cases. Let's for instance take this question. It says design a network with 3 networks: marketing, sales, management. Marketing requires 60 computers, sales requires 100 computers, management requires 34 computers. Now, like in our previous question, 3 networks, you cannot break a network into 3, you break it into 4. But the problem is, the minute you break it into 4, each of them will support only 62 hosts. But we have a requirement for 100 computers in the sales department. But in this, because we need only 3, there is 62 hosts here, that is wasted, right? So better way of breaking down the network is like this. We break 126 as one part, and then you break it into 62 and 62 for the other parts. How do you do that? First, take the highest requirement. So highest requirement is 100 computers. Take your magic table, see how many bits you need to borrow for 100 tables. So we borrow 1 bit. Can we borrow 2 bits? So the minute we go to 2 bits, block size becomes 64. 64 means you only have 62 valid hosts, but we need 100 hosts, so we have to stay at one bit borrowing. When you borrow 1 bit, let's start with 192.168.1.0. so your network ID is 0, but with borrowing only 1 bit, the block size is 128. So the next IP address that's going to start is 128. So the broadcast ID is 1 less, it's 127. In between, we have 126 valid hosts, which is perfectly fine to accommodate our sales department. Now, next highest is marketing department, which requires 60 computers. 60 computers, can we go to 3 bits? We can't, because it is 32. We need to stay at 2 bits. So when we borrow 2 bit, our block size is 64. So we start with an IP address 192.168.1.128, because that's the next available IP address. And we add 64, so that is 192 is going to be here, 1 less than that is 191. So 128 to 191, if you add both these numbers, it is 64 IP addresses. So that's block 64 is the block size, minus 2, you get 62 valid hosts, which is perfect for our marketing department, which requires only 60 computers. So network ID is 192.168.1.128. and the broadcast ID is 192.168.1.191. But remember, here it was /25, but in the marketing department it is going to be /26. Next, we go to the management department. So the management requires 34 computers. We can't borrow 3 bits, because in 3 bits we get only 30 valid hosts. If you see here, 32 minus 2, we need 34 hosts, so we leave it at 2 bits borrowing. And we know the next IP address is 192.168.1.192, and since it is 2-bit borrowing, it's a block size of 64. So 192 and the broadcast ID is 255. The network ID is 192.168.1.192/26, and the broadcast ID is 192.168.1.255/26. It's very easy, isn't it? It is very easy, and it is something I think I mean, of course you require a lot of practice, but if you practice it well, it is going to be very, very easy. So what we'll do is we'll end this video here. We will come back in our next video. We will deal with class A and class B subnetting, and of course we will also deal with another concept called supernetting. and we will try and do a lot of CCNA exam type questions so that we get practicing. And of course, like I have told this before, like I don't think so I can repeat it enough. Please watch this video as many times as you want so that you get thorough with the entire concept of subnetting, and you should be able to do this in your mind. You don't really need to take a pen or paper, you don't need to take a calculator. Obviously you cannot get a calculator in exam, so don't even think about your calculator. But I would say try and get it in your mind so that it becomes second nature to do all your binary, multiplications and binary tables, and all these things should be second nature, so you can quickly find out the answers and your subnettings. If you have any questions, like I've always told you, please feel free to write to me, or you could also comment on the section below this video. Please share this video, please like it, and please subscribe to our YouTube channel. Thank you so much for watching, and I am here to help you anytime you want. Thank you so much. Bye bye.